Okay, good morning, everyone. Like I say, this is a bit strange because I can't see if everyone's here, but it looks like we're getting some messages, so people can hear us. So welcome to day 2 of the Connected Everything conference. So we have a series of presentations this morning before we wrap up, and then we have an early career researcher training session in the afternoon. So for those of you who missed yesterday, most of these talks are pre-recorded, although not all of them. During the talks, you've got the option of writing questions in the Q&A panel on the right-hand side, or in the chat as well. So any questions that pop into your head during the presentations, you can just kind of stick them on there, and then we have a 10-minute discussion session after each presentation where we can go through those. Okay, so to start us off, it's my pleasure to introduce Chris Courtney from UKRI, who is leading the Manufacturing Made Smarter initiative.
Good morning, thank you. Can you hear me okay? Thank you. Let me just pull up some slides and then I shall Can everybody see those okay? Okay. Good morning, everyone. What I want to try and do this morning is to give you an overview of Manufacturing Made Smarter, a little bit of what it is as a reminder of a little bit of context and background, what we're trying to achieve and what's coming up soon, and hopefully that will pique the interest of many in the room. Just a little bit of context is the overall work was launched in 2017 with the publication of a Made Smarter report. The report itself was really focused around digitalization in manufacturing and how it can impact primarily productivity, but a range of other measures within the manufacturing sector. And it was really the launch platform for an investment in innovation, but also in work to seek to get increased digital adoption in SMEs primarily, but also big industries. But it had a fairly bold ambition that by 2030, the UK would be a global industrial leader in creating, adopting, and exporting these technologies. And one of the sort of key phrases is shaping how the world does business. So if you're digitizing the manufacturing and supply chain processes of business, you're shaping how they work. So it's how they manufacture, how they deliver, not necessarily so much what, although there's an overlap between those two things. But the ambition is for the UK to be a leader in that space. So to adopt it and to use it to make our manufacturing and supply chain businesses more productive, profitable, sustainable, and so on. But also to take a lead in shaping the technologies which underpin that transformation. From a research and innovation point of view, which is the piece that I own, it's a fully cross-sector challenge that we lead. We launched it last year, and it looks across all sectors. So primarily aerospace, automotive, pharmaceutical, and food, but pretty much everything that gets made or moved is within scope from that point of view. It is about the core manufacturing processes, the core supply chain processes, and not about just a wider digitization of everything in the manufacturing sector. Technology-wise, it's the stuff that classically gets described as Industry 4. So it is artificial intelligence, automation, robotics, additive manufacturing, IoT, AR, VR, and so on, and other new technologies as they come on stream. So it's not a sort of exclusive list of technologies that are in and out of scope. It gives you an idea. It's a pretty broad range of technologies that are involved. And when the program was launched last summer, it had 4 primary themes: smart factories, connected supply chains, design, make, and test, and adaptable, flexible manufacturing. The principle of it, as I say, it's the work within the factory and how to optimize them and how the technology can transform it, and the same for supply chains. So that was the launch in 2019, and I say that what we all will do is deliver capability which will underpin how the UK makes and delivers products and services. It will clearly enable what we make. So as you adopt technologies, particularly say additive manufacturing, can have a transformative impact in terms of what gets made. But there's also an overlap really between this work and the work that hopefully we'll get some funding in the future or increased funding in the future around the design side and how we really bring together design and manufacturing and supply of products into one sort of interconnected ecosystem. If you step back from an industry point of view, you want to be able to optimize that whole thing end to end. The funding we have right now is primarily focused, or that I'm responsible for, is focused on the manufacturing and supply chain side. So to give you a sense of scale, the government investment in this challenge is going to be 147 million. It'll run until March 2025. It's matched by industry, so in broad terms, they sort of double that and say that it's a sort of £300 million challenge. So significant impact in the business, but equally a pretty broad scope, as you can see from above. The sector coverage, technology coverage, and covering manufacturing and supply chain is a pretty broad range of things. So big opportunity, but equally a lot to do. In terms of achieving it, I think, from my side, we really want to take advantage of the technologies and potentially develop them further, but ultimately trying to deliver a more resilient, productive, sustainable manufacturing sector. And there's a lot of words get added to that. Resilient and flexible are very current terminology. All businesses have seen huge disruption. All have seen the need to be flexible in terms of either what they make or the scale of their operations. But there's a long-standing issue in the UK for productivity where we really need to try and boost that. That said, you're looking forward into the future and the government's challenges around net zero, getting to net zero by 2050. The scale of that challenge for manufacturing, as well as lots of other sectors, is pretty significant. So really we're looking for the digital technology revolution to come on and support a pretty large transformation in that manufacturing sector. That means getting to leading productivity and environmental performance that delivers that, to be leading in the creation and development and delivery of products of the future, the products the world's need going forward into that more sustainable future. The opportunity to really grow that technology sector. So we're exporting solutions, we're developing solutions in the UK, and we start to export those across the world. And I say to be seen as a leader in this space. To really translate a lot of those concepts into reality, a lot of the ideas about how the manufacturing sector might work. I've been around for a while, so it's really how do we translate some of those ideas, take them from early stage research, whether it's technology or business model idea, and actually convert that into reality. So we want to see by 2025 and 2030, the real kind of pull through of disruptive innovation ideas, and they're really being used in organizations. I think in general, across all sectors, the need to become much more interconnected with your supply chain from an end-to-end point of view, but also to take advantage from a national point of view of a wider ecosystem and how to create that enhanced connectivity between suppliers. Particularly, you'll have seen the disruptions that everybody's experienced over the last 3 or 4 months have really highlighted where supply chains are connected and where there is visibility and ability to manage it, and where there are some real challenges. Sector by sector, it's a slightly different story, but the need to create a much more interconnected supply chain is a huge part of what we try to do. And I think, as I'll show you in a second, we want to be able to create a line of sight or sort of networks, if you like, that really link from the early stage research all the way through to the large scale applications. So there is a pathway through. There's a set of integration, if you like, across all the different things that we will do within the challenge to really enable the contribution of everybody and to sort of network all those ideas. So say the leading edge research, the brightest ideas can find a pathway into transform business models, operations, opportunities for companies within the UK. In terms of the stuff that's, you'll see over the next 6 months or so coming through. So this is my attempt, apologies for the bad graphics, at trying to explain what we're trying to do. So it's the purple pieces in the middle. The Made Smarter report talked about digital innovation hubs, research centres, development of standards, looking at how do we get proper adoption, how do we look at the economic and social issues that come with digital technologies, and to really make sure that they get properly adopted. How do we create a set of standards to enhance interoperability and so on? And you'll see that we will do all of those things at a fairly increased pace over the next 3 to 6 months. We want to create that line of sight, as I said, from research to exploitation, so things integrate and they kind of flow through the different mechanisms that we'll start to set up. a lot of those aspects will be aligned to the innovation themes that we talked about or mentioned at the start, and they'll be sponsored and designed and sort of led with industry. There's a bias more towards being industry problem-led, if you like, and really trying to sort of solve those problems, but there is some funding available for opportunity-led stuff. I'll explain that a little bit in a second. We have to create a set of measures, research centres, stuff for technology SMEs, innovation hub environments and so on that kind of work for all. So we bring the best of everyone. So that's technology users, large and small, so the SME through to the large multinationals. The technology developers exactly the same, so that from the spin-outs and scale-up type organizations all the way through to the large players, and to create an environment that really brings the best of all of those together to really take us forward. Create strong collaboration and networking across all aspects. Everything that we do, whether it's the research, the growth stuff, or the innovation hubs, will have a requirement for collaboration and networking. What we put in place, we want to be sustainable and substantial. So it's not just a small thing that will last for the life of the challenge and then stop. We want to try and put in some foundations that will carry on and develop and grow as this area moves forward in the UK. But for it to be substantial means we need to prioritise and not necessarily do everything everywhere, and to be sort of ambitious about what our goals are. I think in the research community, we're looking for that ambition about what does that future really look like, what is the future potential of the technology, what are the future business models that might be effective, and so on, and how can we support some of that. I'd say in general, we'll try and make best use of capability and assets that are out there already. So just a little bit more flavour of what's actually happening. So we did a first round of competitions last year, which was what was called a fast start, so before formal launch of the challenge. There's about £20 million investment from the government side, and those projects are up and running, and they're pretty broad ranging in their scope, pretty fitting with our sector scope and our technology scope. We put everything from stuff in the food industry to stuff in the leisure industry, stuff in the large aerospace, automotive, pharmaceutical type organizations, stuff focused on factories, stuff on supply chain. So a pretty broad portfolio of stuff is launched, and some really interesting projects within that. We've launched a further round of competitions, which is focused on the digital supply chain. There'll be a future one, which is on the smart factory. The supply chain competition opened 2 weeks ago on the 6th of July, closes on the 7th of October. And that's really looking at supply chain design and execution, and how can the technology support that. We've had a really strong pull from all sectors, strong support from the advisory group. And we've seen already in some of the webinars and workshops, a really strong appetite for this area and an opportunity to work across sectors. So there's an opportunity to invent once and use many times across multiple sectors, which is, it looks really exciting so far. And that's because from a supply chain point of view, most sectors they've all seen significant disruption, whether if you're food and the sudden shortage of toilet rolls, or if you're in aerospace and automotive and you've seen a big decline in your markets, pharmaceuticals and so on. So you can imagine each of the sectors has experienced sudden and unprecedented spikes in demand or drops in demand. But they share a lot of challenges, including things like visibility through an end-to-end supply chain. How can the technology help us be able to do that? If you have thousands of suppliers in a very long chain, or you're going all the way back to the raw materials or the agricultural end of things, how do you kind of get visibility throughout supply chain? How do you deal with issues of flexibility and resilience, big changes in demand or changes in what you make and what you deliver? Whether you're in food, aerospace, pharmaceuticals, traceability and provenance of everything is a big deal, either for safety or regulatory type reasons, or reasons to do with ethics and other things. Having an understanding of the full end-to-end supply chain and the provenance of all group goods and traceability through it is a big deal. Use of analytics to optimize production planning and scenario modeling, particularly in these disrupted times. The need to be able to do those models quickly and to optimize a very complex overall system. And things like logistics. Logistics could be autonomous and could be just, it could be electric vehicles with almost zero touch. So instead of the man turning up with his Amazon parcels at your house, he doesn't need to walk it to your house. There's all sorts of ideas about how to really make fully autonomous and low touch, and I say optimized for sustainability. So there's lots of areas across multiple sectors in supply chain that are of interest. We'll do the same type of competition next year for the factory side. And in these projects, the typical model is a large industry player, small industry player, and universities. So there's an opportunity for researchers to play a part in supporting some of this. We will do the factory stuff sort of mid-2021. So towards the start of next year, we'll start to shape what that call really looks like, and that call will come out next year. In terms of the kind of underpinning ecosystem, which is the purple arrows in the middle, all of these things are sort of coming soon, and it's slightly vague about exactly when those things are, just so I don't get people overexcited. But innovation hubs, growth accelerators, and research centres. If I start with the innovation hubs, we're going to create, pretty much as the Made Smarter report called for, a network of innovation hubs where they'll be focused in two areas: the smart and flexible factory areas, so the stuff within the four walls of facilities, and the stuff on the supply chain, which I just highlighted before in terms of scope. And to build on multiple test beds and development environments which are already in existence, but to really boost those and add to those, and to significantly step up our investment in it. We've started to do some development work with that. The full tender will be launched later this year for, if you like, formally setting up those hubs. And I say that the investment over the next 2 or 3 years is fairly significant in terms of the scheme, in terms of this challenge. So I think it'll be a really interesting environment. What we're trying to create is an environment where, again, all the stakeholders can come and really co-create and develop the next generation of solutions in a slightly more representative environment. So say it sits further on the TRL levels than the research centres would. But it's really about getting closer to application, but an environment really where we can really co-create those things with multiple stakeholders. So hopefully a kind of ecosystem will get set up in this space around those innovation hubs, and that'll be a really impactful measure that we can take at a national scale. Growth accelerators, again, will be launched soon. We've actually, the work has started. It's kind of underway, but not public. It will become public in the next week or two. And that's looking at technology, SMEs and startups, how to bring next generation solutions into this space. So there's a lot of investment in the UK in digital tech. A lot of it goes into fintech and other places. We're hoping to both take ideas that people have that are very much focused on the manufacturing sector and see those come through, but also people who are invested in technology that might be used in adjacent sectors like fintech or others, and see those solutions be pulled through for manufacturing and supply chain purposes. We'll have a campaign throughout the challenge of these growth accelerators, an opportunity for very early stage businesses to come through and really demonstrate that they have next generation solutions to industry problems. So that will be framed around industry themes, industry problems, and as I say, the opportunity for SMEs to demonstrate their ability in that space. Research centres, I guess, is probably the closest to home for many of you. The intention is to have some multidisciplinary centres working across multiple universities, and again aligned to the innovation themes of this challenge. And again, it's really the next generation solutions. How do we really transform the manufacturing sector? How do we get to what we said in 2030 and beyond? Both leading performance from the companies within the UK, but also the technology solutions that we think will themselves become world leading and export potential. So the idea is to take, it'll be led by the EPSRC in terms of the call that comes out shortly. It'll be integrated with the ESRC. It's vital that we both optimize the technology and take a look at business models and the sort of human-centered part of that. It needs industry support. So anybody who wants to play a part in this will need to have some industry support and sponsorship, and need to contribute in some sense. But what we're trying to get right is that mix of industry problem-led approach versus opportunity-led stuff. So we have a bias more towards focusing on the problem-led side. So let's really make sure that we're targeting the innovation and the ideas around problems that industry have and can really help them move forward. But there is some opportunity for that sort of longer-term vision and some blue sky thinking. So in summary, really, we were set up to deliver the innovation agenda, and that's my raison d'etre. We'll see a significant ramp up in national activities in the next 6 months. So we've got supply chain stuff which is launched And everything I just described to growth accelerators, innovation hubs, and research centers are all pretty significant investments, and they will all get launched in the next 3 months. So you'll see increased activity in this space, and that's really what we're here to do, is to really have a step up in activity in this area, both from the research side all the way through to the demonstrations and so on. There is a cross-sector advisory group, so all the thinking is that this is invent once, use many times type approach, and we have got a good advisory group which has multiple sectors represented, academia, the RTOs, and so on. A pretty broad advisory group which is helping me shape what we do. And what they've all seen is actually the increased importance of digitalization and automation and other things. And it's vital that we harness that power to really both restart the economy and help accelerate the recovery, but also if you take a longer term view, create a radically new manufacturing approach and ecosystem. So it should look very different. If we get this right in tandem with other investments, then it should look and feel fundamentally different in 10, 15 years' time. A much more vibrant technology sector and a transformed means of production and ways of running its supply chains and different models being set up. We're really hoping this is a significant boost. The ramp up of the program, I've said, the innovation centers, research centers, and the growth accelerators, and say that competition is already open. And I think I came into role in February, and I think the surprise for me was as soon as COVID struck, actually the importance of innovation is intensified rather than decreased. My slight thought was that perhaps it would ease off in terms of the pressure and intensity and the importance of innovation. That's absolutely not the case. All organizations, despite struggling in some cases for what does the future look like for them, they've seen absolutely it's important that to innovate. They've seen the importance of a lot of the technologies we're talking about in scope here, and they think it's more vital than ever that we take the opportunity to really transform our manufacturing and supply chains. And as I hope that we can play a role in making that happen. That's all I had to share from a slide point of view. I guess we're open for questions.
Okay, great. Thanks, Chris. That's fantastic. I think that shows a lot of how we're all feeling as all organisations to adopt a lot of digital innovations, especially from a university point of view. We've had to very quickly adopt digital teaching, etc., and imagine that not just us. So we have a few questions come in. So one from Sarah. So one of the main things we try and do with this network is support early career researchers. And so Sarah's asking how manufacturing made smarter can help support early career researchers and making sure their research aligns with what industry needs.
Yeah, so I think what we'll do, you'll see more, I guess, in the research centres in terms of the themes that we're interested in. I think there is a huge opportunity in manufacturing and from a made smarter point of view to really transform the sector. So one of the things I guess I'm keen to stress is the opportunity to have an impact in the work that people will do is really quite significant. I've seen it for years and years and years, and I think if you fast forward to 2030, 2035, 2040, it'll be a fundamental transformation. And I think the opportunity to shape and be part of that would be exciting to me. If I was 21, 22 again, I come very early and kind of straight out of university and into research, well, I'd be fascinated by the opportunity to try and do some of that. I think it's just trying to, hopefully we'll set up a framework which will give people a bit more direction in terms of here the challenge that we really think we should be addressing, and the funding and support to do that and be part of that. I mean, the research centres will be part of that, and then for my side also, integrating into the wider EPSRC world, whatever I can do to try and support this agenda, not directly through my own funding, but through other people's, if you like, is something I'd be keen to do.
So what would these research centres sort of look like? Would they look like CDTs, or would they have postdocs and permanent academics in them as well? Could they be run virtually, given COVID?
Yeah, so there needs to be there'll be a lead, and they need to have a coordination point, obviously, and a sort of overall management within them. but they'll be virtual in the sense we would expect them to be multi-university. It's not about a single university or a single department. We want to take a multidisciplinary, multi-university approach. So the connected everything model is a good model in that sense. It brings together multiple disciplines from multiple universities, and it's a very similar model. But what we'll try and do is put more funding into that, if you like. So hopefully there'll be a portfolio of sort of core and enabling research, as well as stuff which is a little bit more applied and much more industry led. So there'll be an opportunity for longer term stuff, as well as doing sort of MSc type projects, or shorter 6-12 month research postdoc type work. So it'll be a bit of a mix. And so that will come up. I was reviewing the paperwork for it just before this call, so it's close. The final paperwork is close to coming out.
Okay, cool. Good luck.
Yes, I'm finding a few more hurdles, but it'll come out as soon as we can get it.
And each centre will align with a specific theme that's been identified. Is that correct?
No. It doesn't have to be. So it was one of the design decisions that we took was, do we want, if you like, a smart factory 1 and a connected chain 1, or do we want to sort of open it out a little bit and just see a little bit where there's appetite, so there might be a collection of universities and a collection of industry to support them that say we want to cover more than one theme, or we want to cover all of them. And we're going to be open to that. So there'll be an expression of interest stage, and the purpose of that really is to see what comes back. What's the shape of those collaborations, and what the focus is. So it's not dedicated, one centre per theme. All we've got is a sort of an allocation. Not all we've got. We've got an allocation of money, and the exact size and shape and number of centres, will evolve over the next number of months as we see what the people come together to support it.
So you can use the expressions of interest to kind of influence that, I suppose.
Yeah. Just a few comments on the chat. I don't know if I may come back to those as well. I can see.
Yeah.
Yeah, so Susan's asked the question. There's an overlap really, but it's quite interesting. The wider UK manufacturing or industrial strategy, there's a strong overlap. We have a very strong advisory group that's got lots of industry members, and they all have clearly a say in some of that. So we'll be an enabler for that, but this isn't really the only vehicle by which those things get tackled. So you'd be unsurprised to know that it's a big deal within government about the reliance and security of supply chains generally. So, there have been a variety of shortages suddenly where people realize that they're very dependent on small elements of their supply chain. And that applies in all industries, actually, whether it's suddenly you find there isn't enough glass manufacture, or not enough toilet rolls, or not enough chemicals for certain parts of testing kit and so on. So there is an ongoing review of that. I would say that me personally and the challenge, we're involved in it, but we're not the main vehicle for it. What I hope we can create, though, through the technologies as we deploy them, is a sector which is much more competitive and makes much more economic sense, at least, to have stuff within the UK. The political case, if you like, for being self-reliant and so on is sort of slightly outside my sphere, but I'm hoping that we can help make the case that for companies, as they make choice after choice after choice, they want to come make and deliver goods in the UK, and increase the size of the manufacturing sector overall. Hadi's question, what would be the difference between innovation hubs and research centres? So the research centres are very much sort of university-led in that sense, so industry shaped or sponsored really, but it's a sort of university-led thing. The innovation hubs are probably more akin to catapult type structures, for those who are familiar with those. So we're looking for something which is higher in TRL levels and much more of a sort of integrated solution. So it's a little bit further along the journey. So we would see these two things working very closely together. So, if you had an idea that comes out of a research centre, it should find its way into an innovation hub and then ultimately into successful exploitation. That's what we would hope. Yeah. Tim.
Yeah, I'm just reading that as well.
Ask what the other challenges. Let me just check I understand your question, Tim. Are there any other challenges? There are, I mean, in terms of the scope of this challenge, I've just tried to describe some of that, but there's obvious overlaps with other areas. So if for those of you who are there, will the design stuff, then there's always overlaps within the design. When people are looking at medicines manufacturing, which is another one of the challenges in UKRI, then there's an overlap with E&I. Faraday challenge is the same. So you find that there are some integration points both within UKRI and into the wider world with what we do. Our focus is clear, but we recognise there's some overlap. So the Made Smarter funding isn't the only place in the world where you can find some funding for digital manufacturing or supply chain type projects, because of the widespread interest in the area. So we're not an exclusive club in the sense of this is the only place you can get it, but we are the place that's trying to do the bigger scale national stuff. Tim, hopefully that answers your question. John, no, the catapults have some aspects of this already. They have some areas, so MTC or AMRC as an example, or CPI, there's lots of areas that have some capability. There's nothing right now that says they won't be the catapults, and they won't be a boost to what we do within the catapults, but we're open to there being other options. So it could be that, so industry people have said, could I do this in my facility? I have a training center or a technology center. Could we do it here? Catapults think they're the obvious place for it. And right now we're to the location and the organization that will lead those and trying to work out what the approach is. So hopefully the intention is not to compete. The intention is to add to.
Okay, great. We've got another question from Sarah. Do you think some industries which have declined in the UK, so textiles, for example, will see a resurgence?
I hope so. So there is another challenge called transforming foundation industries. It looks at some of that. In my life immediately previous to this, I actually did some interesting work with textiles and glass manufacturers who were quite small. What they were seeing is the need. So, for example, in the glass example, they had done some low-cost sourcing. That they had pushed some stuff out into Eastern Europe and other places, and they wanted to know, if I use all these technologies, can I make a competitive facility and put it closer to home? They were passionate. They wanted to try and relocate stuff back to the UK, and they thought that the technology was an enabler for that. Same thing for the reliance and UK security point of view. There'll be a tendency to try and pull stuff back into the UK for those reasons too. So say that it's probably a double-edged thing. There's some things that will say, let's bring some of these things closer to home. Let's look at different business models so it's not all made in bulk very far away and then shipped on. Are there different business models that can support some of that? But ultimately, we have to be competitive. Most organizations, you've seen my background is in a lot of heavily engineered products. If you take those businesses, they look around the world for the best place to put their facilities. We have to make sure that UK is absolutely the best place to put their facilities. It has the best people, the best capability, the best outcomes from their side. And a lot of that is an economic case. They focus quite strongly on the economic case. So hopefully we can do a bit of both, that there'll be encouragement. People will want to bring it here. We'll enable that to happen, as well as sort of more political issues around self-reliance and so on.
Okay, fantastic, great, thank you very much. So I'm not sure if you're able to stick around for a bit longer.
I'm not. I might be able to come back later, but I'd say I need to just drop off at 11 o'clock for something else. But if there's any other questions, then I'm happy for people to follow up, make contact with me. I'm happy to.
Fantastic.
Or if they have any ideas, I'm always happy to hear those too.
Excellent. Thank you very much. Excellent. Okay, so that brings us up to 10:50. So our next presentation is by Dr. Kate Black, who's a senior lecturer at the University of Liverpool, whose research focuses mainly on novel inkjet printing techniques. And today she's going to present about the digitalization of a new technique that's just kind of recently been developed at the University of Liverpool.
Good morning and welcome to my talk, Data-Informed Optimisation of Hierarchical Binder Jet Printing. So today I'm going to talk to you about a new additive manufacturing process that's been developed here at the University of Liverpool in the School of Engineering, and how machine learning might be able to optimise that process. But before we do that, I'm going to talk to you a little bit about how we came to develop hierarchical binder jet printing, some of the drawbacks of conventional binder jet printing, because I'm aware some of you might not know what binder jet printing is, so I'll cover that. And then I'm going to talk to you about the hierarchical binder jet printing process, what it entails, and some of the benefits as a result of that process. And then I'm going to move on to some of the modelling work that we've been doing to try and improve the binders itself. And then I'd like to finish really talking about how we might use machine learning to optimise the process further. So hierarchical binder jet printing came out of an EPSRC grant that I was awarded back in July 2017. The proposal was called Reactive Metal Jet Fusion Printing then. And this was a 3-year proposal, 3-year grant funded by EPSRC, and we're just about to come to the end of that. We've got a little bit more of an extension due to COVID. But back in October 2019, we span out a company called Meta Additive. Meta Additive was formed, and that was formed as a result of a direct result of this EPSRC proposal. And that company was founded by myself and my colleague, Professor Chris Sutcliffe, and the CEO of that company is Mr. Simon Scott. So before we talk about what hierarchical binder jet printing is, I thought I would tell you what conventional binder jet printing is and what some of its drawbacks are. So binder jet printing's been around for many decades now, and it's a reasonably fast printing process, but there needs to be some lengthy post-processing steps, and that's what's limiting the uptake of this AM process further into things like automotive or aerospace. So it essentially relies on a powder bed, and that powder bed could be a metal, a ceramic or a polymer. And in this instance, we're going to focus on metals. But it relies on a powder bed that then you spread out a layer of powder, which then has a sacrificial polymer, which is inkjet printed on. So it's jetted onto that powder bed. And that's what binds that powder together. But because we've bound it with a polymer, and we don't want polymers in our metal components, we need to debind. And that debind step can be quite lengthy, anything from 15 hours to a week sometimes, depending on the process and depending on the component. And that debind step often leaves carbon residue behind in your component, which is detrimental to the overall component and limits its applications that it can be used in. It's also a lengthy step, but also if your part is too large, you can't get enough binder out. So it limits the size as well as the complex of the geometry that you can print. You then need to heat treat it to consolidate the component to get a dense component. And again, these can sometimes be lengthy and high temperature processes. And this causes a high rate of shrinkage. So we can see anything up to 40% shrinkage for binder jet printed components. And again, this limits its size and the complexity of the geometry. We can use some careful models to try and predict how things may shrink. But the more complex the component, the bigger the component, the more complex that becomes, and it's not always that accurate. And then sometimes we also need this fifth step, which is a further infiltration process, and we usually use a low melting point metal to do that. So you can hopefully see the steps that are contained in conventional binder jet printing and the drawbacks are mainly porosity and shrinkage. So what we developed at Liverpool was we got rid of that sacrificial polymer, and instead of having a polymer, we used a binder that was functional. So it was made of functional material. And we call it hierarchical binder because it contains 3 components. And the first is a liquid. It's a metal liquid. It's a metal organic. And when that is jetted onto the powder bed, it forms this conformal coating of a metal or ceramic, depending on what material you're using. And that film acts like a cling film and holds the powder together in its 3D structure. And what's held in that solution, that metal solution, is some nanoparticles. And the nanoparticles, they help to fill in the gaps and the interstices of the powder bed, but they also help to lower the sintering temperature because of this high surface area. And then finally, we've got microparticles. They fill in the remaining gaps, and they can be anywhere up to around 5 micrometers, depending on the size of your powder bed, depends on what size particles you can have in your binder. So we can see why it's hierarchical, because we've got molecular solution-based metal, we've then got the nanoparticle metal, and then we've got the microparticle metals, and they help to bind and also infiltrate the powder bed that you've got. So what we see is we go from this conventional 5-step to this new 3-step. So it's reducing the amount of manufacturing steps and reducing the complexity of the process. So we still have the same powder bed, but instead of infiltrating with a sacrificial polymer, we infiltrate and bind simultaneously with build material, this hierarchical binder. And that limits the shrinkage, but also lowers the sintering temperature and the length of time that we need to heat treat. So from our models that we've done to simulate this process, we've seen that for green part density, that's green part density, not final density, we can get infiltration of around 87% density. So that's very high. And as a result, because you're not removing any components from the powder bed, you're actually infiltrating it with build material, the printed parts we've got with the best shrinkage rates is around 2%. So that's a massive difference and a big improvement on conventional binder jet printing. But I think what the beauty here is that we can, the added benefits is because you've got build material from the inkjet head and you've got build material coming from your powder bed, we can start to print in one printer multi-materials, because that binder could be one material and the powder bed could be one material. And in the binder, the molecular bit could be one material, the nano could be another material, and the micro could be another material. And we could start to see how we might process some alloys or different materials, how we might be able to do printed graded structures. So we could have a head with one material in it, another head with another material, and you can start to see how we might build up much more complex materials in complex geometries in additive manufacturing for the first time. Some other benefits here is the fact that we're infiltrating and binding simultaneously means we could just do a multiple deposition step. So we could print more binder, more infiltrate, and we could tune the densities that we need depending on what application we're using. We also find that we get a much lower contamination of the final component, and that's because we're not using sacrificial binders, so we're not having to heat treat the binder out, and which often leaves this carbon residue. So the contamination of the final part is much lower. But really, I think the biggest benefit probably is this improved green part density and green part strength. Because you're infiltrating binding simultaneously, your green parts of the density and the strength of the component as it comes out of the printer before it's even had a heat treatment is much higher than conventional binder jet. That means that we could perhaps produce larger components, print larger components, and components that don't need support structures or as many support structures, because they've got that integral strength already. And if they don't need the support structures, you don't need to remove them after, and that's removing this more complex, lengthy processing steps. And if we can remove processing steps, we can hopefully lower the cost at which we can produce metals by additive manufacturing. We're also seeing that, metal components are conventionally used in additive manufacturing are produced by laser powder bed fusion, but we see if we can use it by binder jet printing, we can up the speeds at which we can produce bespoke metal components. So we could start to see other sectors taking this process and producing components that are bespoke in nature, but the speed is much faster and the cost is lower than, say, laser powder bed fusion. And that's because of removing all these processing steps and the fact that it's not a laser-based process, but it's a print head process. But the most fascinating, the most exciting for me really is where this technology could go. And because of that ability to do multi-materials, could we start producing components with embedded functionality? Maybe there's a printed strain gauge there, or a sensor in there. So it becomes really exciting of where additive manufacturing might go and where we might use it, and what applications and sectors it might be applicable in. But instead of doing lots of lengthy experiments that are time consuming, can we use some statistical modelling that might be able to optimise this process? And that's what we've been doing recently, and we have a paper that's just recently been published in the Journal of Additive Manufacturing. And one of my postdocs has been using Monte Carlo simulations to model or predict the critical radius of the particles you need in your binder to be able to pass through the powder bed. So what we see on the right hand side here is a simulation of a powder bed, a particle being dropped onto that powder bed. If the particle's too large, it will get blocked. It gets blocked halfway down the layer of powder, which would be no good for us, and it would have a detrimental effect on our overall porosity density of the component. The left-hand side is showing one that's at 2 microns in radius, and that can percolate all the way through the powder bed. So it's really about can we use these mathematical models to predict what's the best size fraction and the size range that we need in our binders, so that they will percolate and penetrate that powder bed uniformly and get the best density and shrinkage as a result. And this is some very quick experiments that we use to validate the mathematical model that we developed. First of all, we've determined that from that model, the green part densities we can get are 87%. But also it shows us that if our particles are too large, they'll just sit on the top. And that's what you're seeing here on A and C. You're seeing a droplet of binder onto a powder well. This is a copper binder onto a titanium powder bed, so that you can see the material difference. If the particles are too large, they just won't penetrate the powder bed and they get stuck on the top. You can see from the bottom B and D here, when the particles in the binder are smaller and lower than the critical radius of the powders in the powder bed, we see that we start to penetrate through that powder bed, and that hopefully will give us an optimised density and lower this shrinkage rate that we see. So from these models, we can then start to print some components, and here's a little video that we've got. This is putting a layer of powder on, and then we're using the inkjet head to jet this hierarchical binder to print some tensile test bars. There we go. So we've got 4 tensile test bars there. And so this model we can use to optimize the formulations for the binders, and then we do the characterization, we do the printing and then characterization. So what effect does the particles have on its overall density and the strength? And these are the things that we're using to optimize our process. These are some models that we've used, but what does machine learning hold for us? And can it be used to not just optimize the binders, but the whole printing process? And this is something that I'd like to talk to you and discuss with you all, hopefully in the next 10 minutes when we have our discussion section after the talk. Can we use machine learning algorithms to optimize the new printing process? So you see on the right hand side, this is one of our hierarchical binder jet printers that we developed at Liverpool and through Meta Additive. And why do we need machine learning? Well, this is a brand new printing process, so can we use it to speed up the optimization of the process, but also help to validate and adhere to standards, and also understand the printing process and its limitations? And we've done this. So with my colleague Peter Green, we've shown that we can use some semi-supervised machine learning to look at fault detection in laser powder bed fusion. So can we translate that into this new printing process? And some of the parameters we might monitor, for instance, could be the dosing rate, atmosphere, the humidity in the chamber, the printing chamber, the layer of the thickness, and the bed temperatures, and how that might affect the chemistries of the binders. So this is something that we would like to look at next. And I'd like to discuss with you shortly about that. So we've seen that the hierarchical binder jet process offers lots of benefits, but can we use modelling and machine learning to really optimise this process further and speed up the optimisation process? So we've got an opportunity to get an integrated sensing system in there. We might be able to develop a database approach to predict the quality of the parts and generate these predictive models that can inform and improve the overall process. So I'd just like to say thank you and acknowledge some of my co-workers here, some of my PhD students, and some of the companies that have been working with us on this project. So thank you for listening.
Okay, great. Thank you very much, Kate. That's fantastic. Are you there?
Sorry about that. Taking some time. Yeah.
So fantastic. So obviously it's quite a new technology. What do you see being the kind of main challenges or main sort of barrier to adoption in the next, I don't know, say 5 years?
I think probably the materials side, we're going to have to demonstrate that they have as good, if not better, properties to existing AM components. I think if you can improve the speed, which I think we can with this technology, then it opens up more markets, more sectors that will take on additive manufacturing. So I think it just shows, because there's so much novelty to this. There's things that have never been done before. I think it shows really what machine learning and modelling could help us and speed that whole process up so that we can get it out there to end users.
Yeah, it's a nice opportunity to get something at the early stage of its development, I think.
Yeah, and I think not many people have that opportunity. If you look at the existing additive manufacturing technologies, we're now trying to apply machine learning to those to understand how they work, whereas we've got the opportunity to grow and to modify the process as we go along, because we now have access to things like machine learning. So yeah, it's exciting, really.
A question from Stefanius. So the modelling of the Monte Carlo simulations, would it be possible to model it through ant colony optimization? So
Good question. As a chemist, I'm not sure. Yeah, I was hoping you guys might be able to tell me whether that's possible or not.
So I think from what I remember, one of the Monte Carlo was used in this case because there's the particle size is uncertain, but you can get probability distributions over the particle sizes, and so the Monte Carlo element was to kind of account for that uncertainty.
Yeah, I think for us, I mean, I'm not a modeler myself. I'm a chemist and material scientist by training, but I understand how complex it is because there's a lot of things going on in there. There's not just the size of the particles in the binder and the interaction of how they interact with the powder bed. There's also the fluid aspect of that and how does that affect it. Sometimes we introduce temperature into the powder bed. What effect does that have? The vaporization of the solvent that we use as the carrier vehicle in the binder. Again, all of these things are unknown, really, because they're so different to what conventional binders are using. They're normally just polymers and burnt out. So I think there's a lot of novelty in there, but there's a lot of unknown. And do we even have the models to be able to predict how they behave, or do we have to look at them at separate entities? So do we look at the particles first, then how the fluid interacts? This is something that we're learning, but I don't know if any of you guys out there listening have any techniques that you've seen or you've used it for other technologies that might be applicable.
And so you mentioned the potential for multi-material AM. What kind of application areas might that have out of interest?
Well, I think there's some existing technologies, so many in the energy sector. Or we could have, even in the automotive, you could have smart intuitive components, so they could have strain gauges or sensors embedded in them. so that we can monitor the performance of components, or even on a security aspect. So where have they been shipped, or can we put some sensors in there so that we know that they're our parts and they haven't been modified, tampered with, or somebody else has tried to manufacture them. So I think there's a lot of scope there. But what fascinates me is really what could be possible because of multi-materials that people just haven't even thought about before, because it wasn't an option. So you know, who knows really? But I think it's the most exciting part for me of this technology, where it could go. First of all, we need to show that it's comparable to say things like laser powder bed fusion. It keeps up the material standards that we need. But then the next aspect is, how do we do graded structures or embedded sensors within those components? And I think that's where the interesting part comes in.
Okay, excellent. We've got a few more questions coming in. So I'm going to attempt to say this word, and I'm going to get it wrong. Are you using a phenomenological model or physics-based model for
I'm glad you said that, Pete. So this is a physics-based model at the moment, and we are doing physics-based modelling for the sintering, but we're trying to see whether there's other options out there that would give us a much more accurate model of what's happening in the system, because it's so new. I think the closest thing we can look at is some aspects of, say, soil science or geological, looking at fluid going through or gas flow through rocks. We're starting to see some similarities to our process, but really this is unknown. So we've done a very sort of basic model that people can go and look at the paper and look at that in more detail, but it's now, can we bring in all the different components and the aspects of that? And myself, I really don't know. Yeah,
fair enough. So a question from Deborah, because we have an early career researcher training session later today. So Deborah's asking, what's your top tips for achieving successful funding applications with industry involved?
That's the most important thing, because it's very disheartening. Particularly in industry, I think that all of my research is funded with either fully funded by industry or part funded by industry. And I've found that industry has been very open-minded with what we've got. So I think, don't hold back, visit as many conferences and as many people as you can. Go out there. I mean, these type of things online are great as well, to just build up your network of people. And they may not be quite the right industrial partner at the time, but then I've often found maybe months later, or even a year or so later. So I think it's having those chats with them. Don't be afraid of talking to them, because 9 times out of 10, they're more open than you think they are going to be.
Yeah, I think I'd echo that. I think half of the battle is just them knowing who you are.
Yeah, and the fact that there's an academic reaching out to see what industry is doing. They appreciate that, because there are many academics who go, okay, well, I've made this lovely molecule, or I've made this material, but now I'm just going to leave it to somebody else to do. And I think it's bridging that gap and showing your openness and willing to have those conversations.
So we've just got very quickly, just final question from Sarah. What are the main barriers to adoption of additive manufacturing, as assurance, cost, scalability, for example?
Yeah, so, well, I think cost is a really big thing here, because although the components made by, say, laser powered bed fusion are great, they're still very costly. They're still quite time consuming. People have this naivety that AM is so fast, and it's not actually. So I think, and this is what we're trying to do with our technology, is to take additive manufacturing to the masses. But obviously, you've got to get the material properties right, but it's bringing that cost down and the speed at which we can produce components. If you can do mass manufacture, but with the added benefits of, you know, bespoke, unique, one-off components, then the world's your oyster, really. So cost is a big thing.
Great, thank you very much. Okay, so if you're able to stick around, I think there's still a little bit more on the chat.
Yeah.
So now we're going to move on to our third talk of the day. So this is from Heli Frosterus from Ofcom, and she's going to talk to us about some of the challenges that you might face trying to embrace wireless sensor networks, for example, wireless technology.
Good afternoon. My name is Heli Frosterus, and I'm one of the Spectrum Policy Advisors working in Ofcom, trying to promote the use of wireless across various industries. I'm going to start by saying a bit about Ofcom. So we're obviously the UK's communications regulator, and we regulate all communications, really, anything from post to BBC and 5G. And spectrum is also within our remit. So spectrum is really the raw material for any wireless connectivity, may it be from your car keys to the latest mobile technology. So this is what my presentation will cover today. It's all about digital transformation and how wireless connectivity plays a key role in getting the full benefits of all those new technologies and really getting the cost savings and efficiency improvements, etc. There are different ways of connectivity, and different technologies are available. So I'm going to cover kind of some of the choices you have to make when you're considering the right choice for you and the right solution for you. And then obviously Ofcom's involvement. We're really wanting to promote digital transformation, and we are taking steps to make it easier to access spectrum, the key ingredient behind all wireless communications. So we see a huge potential in wireless technology transforming the kind of industry sectors. I think the best combo is when you join the handling of data and the latest developments in AI, cloud computing, etc., with the right sort of connectivity layer. That's when you can kind of maximize the benefits. And obviously, quite often 5G is mentioned when kind of thinking about industrial wireless use, and of course 5G will unlock some of the use cases in terms of delivering more capacity in the network and being able to connect more devices to your network. And also that sort of instant response, lowering the latency, that will also make some use cases possible that weren't before. But it's not all about 5G, and I hope that will be the one kind of main kind of news that I want to make, is that really that to show the possibilities of other technologies. It all starts really from recognizing your requirements, and this is really key. It's not just thinking about cost requirements or the kind of capabilities of the networks in terms of capacity, for example. So if you're looking for a very low cost option, you might find something that is not necessarily then giving you the full capacity, or vice versa. You might not need that much data moving in your use case, but you can really find off the shelf like DIY network solutions that can be really cheap. Other thing is to note that only once you are fully aware of all the requirements you have, then you can start to assess what's the right technology and also what's the right business model for your case. And there's not just one list of requirements. So this is a kind of example of a production line. So you might have 4 different steps on that production line, and each step might have different requirements and different sort of capacity needs, for example, or the latency of that network. So you might have multiple solutions within your factory, for example. Then a bit about the technologies available. So obviously mobile network technologies is quite often as seen as the what is wireless connectivity is the mobile technology. So obviously there's a lot of use of these, and especially on the consumer side. They are usually public nationwide networks, but nowadays more and more also private networks, and I think in the future we will see a real trend in kind of MNOs, the mobile operators, creating private solutions for industrial setting more and more. With 5G, there's also the possibility to have a slice of their public network, so that's not fully private network as in private infrastructure, etc., but it will be private on a kind of software level, if you will. So the slice will give you control of your network. Then the other category of technologies is local area network technologies, the most common one being Wi-Fi. And we're seeing more and more use of Wi-Fi in an industrial setting, not just in enterprises or in a sort of office environment where laptops are connected with Wi-Fi, but also sensors and other kind of industrial use cases using Wi-Fi. There is a new Wi-Fi standard coming, Wi-Fi 6, that will bring some capabilities that are kind of like 5G and are quite often seen as complementary with each other. So really unlocking new use cases. Then there are low power wide area network technologies. So these are very good, for example, if you want to put a sensor under a bridge to measure the vibration of the bridge, and then you put a LoRa kit there, it will have a very long battery life, for example. It transmits only a small bit of data, and it doesn't have to be instant, the transmission of the data. So that sort of solution works really well. But LoRa and Sigfox and also narrowband IoT, we're seeing more and more being deployed, especially on agri-tech, utilities, all sorts of tracking and security solutions as well. And also smart city deployments like kind of intelligent bins or street lighting, etc. So here is still, again, like a summary of these technologies. I'm not going to go through all this, but just kind of wanting to highlight that with all these different technologies, there are different business models available and also different spectrum options. So for mobile technologies, there is nowadays also ability to access those bands yourself without the need to go via the MNO. So we've released a new sharing regime, which is all about giving access to a localized area where you can deploy mobile technologies. Then obviously Wi-Fi is license exempt. You don't even need a license to use Wi-Fi or other local area network technologies, as well as some of the low power wide area network technologies. So Sigfox and LoRa, from a spectrum perspective, they are free, and then it just depends on the business model, whether it's a private or public network, and etc. So it's really about understanding the options and the requirements, and then you get the full benefit. So kind of I said that we're really keen to enable various digital transformation initiatives and to learn what are the requirements. So we're listening, we're engaging with various sectors, and as I said, we've recently made more spectrum available for industrial use cases. We've had events, and now we're doing webinars to really engage with new stakeholders and get our message out there that Ofcom is here to listen and to enable whatever people want to do and make the use of spectrum as efficient as possible. If you have any questions, just let me know. Thank you.
There you are. Hiya. Excellent presentation, thank you. I guess my first question is, if I owned a business and I wanted to consider adopting more wireless technology, what would be the kind of first questions that I need to ask?
So it's all about how much capacity your solution needs. Are there specific security elements you have to take into account? Are there like resilience? Does it need to have a backup system or some sort in place? And then obviously, what's your budget? So I think it is all about kind of understanding the long list of your needs, and then kind of understanding what the technology can do. So quite often people find workable solutions from off the shelf, which can be then scaled up if your business or if your use case kind of grows. So you might start with one LoRa gateway, and then when you need more capacity, you just deploy another, rather than go all the way to a heavy duty mobile base station.
Yeah. I've got a question in from Sarah. So some manufacturing companies have been anxious about wireless technology due to security concerns. I was just going to ask this actually. So how well do wireless solutions address these security challenges compared to closed systems?
Yeah, I think more and more as the technology develops, the security aspect is coming more and more integral part of the technology. The whole standards that they use, the kind of because it's more and more cloud-based, so it more and more goes into kind of the software layer, and then there is basically more attack surface, but then again, it's also better coded. So I think especially if you think about your home Wi-Fi network, it is surprisingly easy to hack that network. But if you have a secure Wi-Fi, like closed, not open Wi-Fi, and then you have the latest drivers and kind of use the latest updates and newer technologies, that's getting more and more secure all the time. But it is true that, for example, I've heard a car manufacturer say that never in a million years we're gonna let anyone else kind of take control of our wireless network. So we have to manage that ourselves, and because if you think about the daily value of your production of the cars you put out, so it's massive. So yeah, I think there is a increasing awareness of the security elements.
Yeah. Have you seen any kind of case studies where the adoption of wireless technology has really transformed a particular business or a sector? Yeah,
definitely. I mean, just last week I heard from a council in Peterborough that they deployed LoRa gateways in their bins, and they have had a 70% cost saving because they know when to empty those bins, and they don't have to go through all of them like every day or whenever. So they empty them only when they are actually full. So it can be very, very kind of simple solutions really. But the other, I think one of the key use cases I've heard in terms of like manufacturing sector has been really the use of remote engineers with that you have a junior engineer on site on location, and then you have more senior engineer somewhere in your main office or wherever, and then with VR glasses you can kind of guide that junior engineer to have to do sort of repairs in the machines, or just kind of check that everything is working okay. So that especially in this COVID situation and with kind of multinational global enterprises, that's been a very success story, kind of having that sort of low latency wireless kind of extra pair of hands.
Yeah. I've seen a few examples as well where it's been very useful to, rather than send engineers out to, say, repair a particular machine every 6 months or anything, been able to collect data wirelessly from that, so they just need to go when they need to go. It's led to huge cost savings and that kind of thing. So a question from Deborah essentially says, why is 5G seen as like the best, the ultimate? Is 6G a pipe dream?
So I think it depends who you ask in the kind of sector, but there are voices that say that every other generation of mobile technology is really good and every other is not. We think about 2G, how that revolutionized a lot of things. Then 3G was kind of like, yeah, you could maybe browse your web a bit, but it was the cat videos with the 4G that really kind of then again made a like a step change. So some people say that 5G will be just another step, and then 6G will then kind of deliver what 5G was kind of supposed to deliver. So yeah, I think that's some voices, but also I think 5G, there is a step change in so many aspects. The use of multi-MIMO solutions, for example, so you get from a mobile mast, you get multiple out and multiple in, more efficient use of spectrum, and also the kind of beam forming that you can track you on the street and the beam follows you rather than kind of gets a signal everywhere. So there are like those new kind of things that really make 5G different from other technologies, but it is always, is that technology mature enough to deliver all those kind of promises and all that hype?
Yeah,
that's the question.
Yeah, it's amazing, isn't it, how quickly as human beings, I think we can go from, there's a new technology and it's amazing, we can do all this new stuff, and then extremely soon afterwards we're kind of fed up with that and we want the next thing. We're all used to it kind of straight away. So we've got a load of academics kicking around here. If there's something that academia could do, is there like a fundamental challenge that you can see that needs fundamental research for the next 5-10 years?
Well, I think there are some solutions that are kind of now popping up, or kind of questions popping up with more adoption of private networks in manufacturers or kind of other sectors, where you have the handover between a private network and then the public cloud, for example. So if you think you're producing some good and then it leaves your factory and you want to track it, how you do that roaming and how you make that kind of barrier work kind of seamlessly while still having the security elements that nothing is coming to your private network that you don't want to. So I think the roaming aspect is definitely one that has raised more and more questions, and how people can kind of manage that. I think how people are now managing that is just having like for example, 2 SIMs or 2 sensors, and the other one is for the private and other one for the public. But I don't see that as a long-term efficient solution necessarily.
It seems a bit crude, I guess, compared to amazing technology.
Cost, essentially.
Yeah, sure. Yeah. Okay, great. I'm not sure if we've got any other questions coming up. Okay, so if we don't have any more questions, I think we can all thank Heli for an excellent presentation. Thank you for answering our questions.
Thanks.
So that brings us to the end of this morning's session. Oh, hello, Sarah. All right. So once again, thank you to all the speakers today, all really good presentations, and yesterday as well. And thank you to everyone for participating. We've had really good discussions, had a lot of useful outcomes from the interactive whiteboard sessions yesterday. Sorry we couldn't have you actually here in Liverpool, but hopefully at some point we can show you the city because it's ace. Special thanks to Nick and Deborah, who were invaluable basically in getting all this sorted out, and of course Sally and Joe, who have been helping us out throughout the whole conference. Now I'm just going to hand over to Sarah for some concluding remarks on this morning's session.
Thanks, Pete, and thank you to you for chairing, but also very valiantly responding to the, I know we used the word unprecedented before, but the unprecedented challenge of having to move a face-to-face conference into an online format, and just working out the best mechanism for that. So thank you, and we will come to Liverpool one day, I'm sure. So to close by, I'm just looking to see, okay, great, we've got the presentation up. So I just wanted to close by reflecting on some of the final presentations that we've heard on, and updating everyone on what's coming next for the Connected Everything Network. So the first thing is we've had a really great range of contributions to the conference, and I think one of the things that's really quite special about the Connected Everything Network is the focus on early career researchers. And if you remember, one of the things I said in the opening remarks is, you know, we're really trying to, I think, break the hierarchy in terms of the different types of presentations we get. And I'd just really like to thank everyone who's contributed in their presentations, because I think we've had a brilliantly diverse set of presentations that have not only given us different technological perspectives on digital manufacturing and the ways that we need to advance and accelerate the implementation of digital manufacturing, but also different perspectives from an academic point of view in terms of the different types of challenges that we need to address. This morning's sessions have been great, thinking from a sort of systems and strategic perspective about the Manufacturing Made Smarter initiative, and then the really sort of focused considerations of some of the absolutely critical technologies that we're going to need to use to enable digital manufacturing technology in the form of additive manufacturing and wireless technologies. So sadly, there were no fireworks as part of this online presentation, but I just wanted to sort of end with sharing some confirmation, really, of what's going to happen next. So first of all, thank you to everyone who participated in the workshops yesterday afternoon. As you all know, we try and identify thematic areas to provide a focus for the work of Connected Everything. And the workshops yesterday were deliberately designed to help us shape and provide some focus to our new themes, which are looking at creativity and design, data-rich socio-technical systems, and then the regulation and standards sort of area that we're working in. And we introduced the new concept around resilience as well, that is really coming through as we understand what digital manufacturing technologies and systems we need to develop. Those themes will inform the feasibility study funding call that we're going to have later this year. So this will be our third call in this particular network iteration. We are looking for an increased focus on industry partnership as well. So those of you who are from an industry background, if you have particular thoughts about the ways that you might be able to co-fund feasibility studies. That's something we're really keen on in order to boost the number of studies we're able to fund through the Connected Everything mechanisms. Our summer school last week was a great success. We are really, really keen to replicate that next year. Hopefully there will be at least an element of in-person meeting in 2021, but the call is going to go out for offers of delivering the summer school in early 2021. So please do think about whether that's something you could offer. The summer schools can often be quite focused on a particular topic. And obviously it makes sense to focus that topic around an area that a particular university or research environment particularly focuses on. So don't think that a summer school needs to be about everything there is to do with digital manufacturing. It can be about something that's quite a deep dive into something specific. So, for example, data-rich environments or specific manufacturing technologies could be a focus. One of the things that we have got funding for, but understandably in the light of COVID-19, we are changing the timescale on slightly, is the funding for placements. Our industrial placements and our exchange placements were really successful actually in the previous iteration of Connected Everything. We've put those on hold. And we will be, as soon as we're in an environment where we can see it's realistic to enable people to work in different workplaces, we will relaunch that particular call. So I just want to close by saying thank you. We will be sending an evaluation to your inbox, so please do complete that, particularly to give us feedback on how the online format has worked and help us to plan 2021 events. The presentations that have been given over the last couple of days will be available to you on the website or via the website. So if you want access to those, please do get access to those. If I can add my thanks to our conference organisers, Deborah, Sally, Pete and Nick. It's been brilliant to see this all come together, and I hope it's been a really valuable experience for you. And although this is the last presentation I'll be doing, it's not the end of the conference. So we've got a networking period now. Please do feel free to go to the small tables, which I think we've all worked out the social protocol to how to go to the different tables and meet other people. And I know a number of you are also attending the Early Career Researcher training session at 2 p.m. later today. So I'd just like to close by saying thank you to all of you for participating. Thank you to all of our speakers. Please take care of yourselves, and we look forward to continuing the work of the network over the next few months and for the remaining 2 years of the funding. So thank you all very much.